So you get yourself a IR6500 rework station and you want to do some reworking. What are you going to need? Well, probably you're not going to necessarily need any kind of software, but software makes it a lot easier to work with it and gives you some abilities that normally you don't have using just this interface, these buttons over here, right? Luckily, the station comes with a coaster. It's a coaster, right? Now, if you're old enough to know what this is, you're probably not old enough to have the hardware that actually reads these. So we're going to use it appropriately as a coaster. So now that we found the appropriate use for the coaster that came with the device, let's go to the URL printed on the device to download some software, like people in 2025. Well, that doesn't seem right. First, the page doesn't use SSL. Second, it doesn't seem to be related to rework stations whatsoever. So the next step, we read what this little controller here is, and it appears to be PC410. Let's look for that. We can quickly find out that it is technically made by Altec. Let's go to their website. Same thing. No security, and obviously your antivirus will block the download of their test software. Now, I haven't seen that software, but since it's labeled as a test software, then it probably just allows you to test the controller, not actually use it for rework work. So you look back to this one and think to yourself that let's see what's on this disk. Since it's 2025 and you probably don't have anything to read this, then you ask your older friend that still keeps those useless devices and reads this for you and tells you that there is a virus on it, or spyware, or whatever. Now, in all fairness, if you write a software and you implement some kind of method of authenticating the use, this might be classified by antiviruses as a spyware because it wasn't implemented correctly. But even if that be the case, this is free software, or it's supposed to be free software for you because you already paid for the device. What kind of device comes with no software? Now, luckily, this device does not need a driver. You just connect it to the computer and it should show up as a COM port or a serial port. So let's see what other options we have. Now, there is no direct download link to this software just yet. If you want to obtain it, join my Discord, and in the motherboard repair channel, the links are being posted where you can download the latest version. Current latest version is 1.4. It comes as a self-contained version, which means it weighs, well, as you can see, over 200 megabytes and even more when you decompress it. Now you have two options, either self-contained or framework dependent. If you choose the framework dependent version, which is like maybe 2 megabytes, you need to have .NET Framework 8 installed on your device for the application to run. So first, we're just gonna extract it all. We can extract it here. Once extracted, we just hit setup. Yes, I'm an unknown publisher. That's me. And we're in. Now, let's turn on the machine and connect it. After connecting, it might take a minute, maybe even 2, before the actual COM port shows up. The system needs to install drivers to this generic RS232 adapter. Once it did, let's right-click on the Start menu and go to the Device Manager and look for COM and LPT ports. And we can see that it has been installed as COM5. Armed with that knowledge, let's switch to COM5. If you don't see your COM port on the list, you can always write it, like maybe your COM is COM15. Now the only supported speed, you can select more over here, but the only supported speed is 9600 bots. And hit connect.
Connected.
Okay, once you hear the lady say that you're connected, you're actually connected. That doesn't mean that just the port was opened. It means the port was opened and we're receiving data from the machine. You can see the buffer load TX and RX. That's the transmit buffer and receive buffer. And you can see the actual temperature. So if we touch the thermocouple on the machine, the temperature will rise. If we release it, the temperature will drop. The purpose of this software, main purpose of this software, is to remove the need of storing programs on the device. Device only allows you to store 10 programs from 0 to 9, or 10 profiles, and you have only 10 channels to do that with. You also are limited to 8 steps as far as the machine goes, but the software allows you to go over 8 steps. Instead of storing those programs in the actual controller, we can store it over here. So we can load the preset that I use for LGA1151 socket. We heat up to 260 degrees. We hold it for 60 seconds. Then we heat up to 225 for 40 seconds and 235 for 2 minutes. Now that 2 minutes is a little extensive, and usually I terminate the program as I see that the socket has dropped, or when I desolder, once I lift the socket, I terminate the program. So it's a little bit extended. 120 seconds is not necessarily needed for this socket. For AM5 socket, on the other hand, as you can see, we go to 245, and that's our 80-second window where the socket is supposed to drop. This is all for tin solder. If you're using lead-based solder, the temperatures can be lowered, and there's going to be an additional profile for that. But if you don't want to wait for that, you can change this profile to whatever you want. So let's do 135 and 125, or 225, and here maybe 200. And let's reduce it perhaps to maybe 60 seconds. And we can store this preset as LGA, or no, was it AM5? AM5 socket. Let it solder. And now we can use that. We can use that profile. So we can load it and upload it to the machine. So let's upload it to, say, channel 8, because you gotta upload it to some channel. And it is now uploaded. So if we hit start now, we will, you hear the machine clicking, and you see the temperature rising. The red is the current temperature, the blue is the set temperature, right? But let's terminate that, because on this machine, as you can see, we can only control the upper heater. We don't have the control over the lower heater. So typically what I used to do is just set a program, say 0, and if we download it and move down so we can see, you can see that we just turn on, we put the set point to 5 degrees and we hold it for 600 seconds. That allows the bottom heater to heat up the machine, to heat up the board to whatever temperature we set it on the second controller. We cannot directly control that, but that gives that forces us to have another step. What if we don't want to do that? What if we want to, let's select a channel 1 for per se, and let's do this socket, the 1151 socket, Right. Let's upload it to channel 1. Right, so now when we hit start, it's gonna start heating to 160, then to 225 and to 35. But our board is cold, and by the time we heat up the board, so by the time the bottom heater actually heats the board to the proper temperature, we will already be halfway through with our actual program. We don't want that. So for that, we have additional option over here as smart preheating. For that, we need to select the channel that we want to use for that. I typically use 0 for preheating either way. That means that the preheating profile will be uploaded to program 0. Then the program will be started. And as the temperature stabilizes based on our threshold over here, this means that if the difference between the average temperature and maximum temperature is lower or equals to 2.0 degrees Celsius, we consider that the temperature has stabilized. And we're going to see it on the graph. Now you can decrease this value if you want to have a higher precision. Perhaps maybe precision is not the best word, but basically you want the temperature to be more stable. If you increase this, the temperature can be less stable. So in this case, if your temperature fluctuates by more than, say, 5 degrees, then if you set it to 2 degrees, that will stop the preheating or conclude the preheating stage prematurely. If, on the other hand, no, actually, sorry, I said it backwards. That will not terminate the preheating stage will be prolonged unnecessarily if there is fluctuation. So if you have higher fluctuations, then set this to a little higher values, perhaps 3 degrees, maybe 4 degrees. If you have relatively stable temperature on the thermocouple, meaning the thermocouple is properly attached to the board and there's not much draft in your shop, the temperature is relatively stable, then this number can be low. So now let's set on the machine, let's set the preheating to say 130 degrees. So 130 degrees on the bottom. The thermocouple is attached to the board, not to the heater. That is one of the mods that you need to make to get better results. But even without that, this is fine. You can use it as a stock machine, but I highly recommend that you mod it. So what's going to happen now, when I start the program, the program will go into preheating stage and wait for the temperature to stabilize at some point. Let's see.
Preheating process started.
Now you can see that our temperature is constantly rising, so the software sees that and keeps it going until the temperature stabilizes, until it reaches a stable temperature. So because the software doesn't know what temperature you set for the bed, because there's no feedback, there's no second channel to actually control that. But we don't need to have that value. All we have to do is just wait for it to stabilize. Right now my bed temperature or the bottom of the board is heated to roughly 90 degrees, which translates to 47 degrees. And we can see that it's starting to stabilize. It has reached its maximum temperature. The bed temperature is at roughly 120, half of what we see on the board.
Preheating stage complete.
And now we're going to the actual program. As you can see, the power of the top heater is increasing. And we're going to go to the first step for 60 seconds, which is 160. And the ramp speed is set to 0.7 degrees per second. Now at the bottom we see which step we're in. We are at step 0. That doesn't mean the actual step that you see over here that we have 8 of. This is the cycle. Right now we're ramping up, so that's cycle 0. Then cycle 1 will be dwell time. Then cycle 3rd will be ramping up or down to the next step. Then the dwell, then the ramp up or down and dwell, and so on. So this is not the actual step number, this is the cycle number.
Step updated.
Now we switch to we switch to the dwell. We're still in step 1, but we're at cycle number 2. So now we see that temperature overshot a little bit. You can constantly see how much power is being delivered to the top heating element. Now, as this controller is relatively simple, all it does, it just reads, the actual physical controller, not the software. It just reads the temperature. If it's lower,
Step updated.
now we switch to step number 2. We finish the dwell. Now, if the temperature on the thermocouple is very low, say 50 degrees behind or 100 degrees behind, what the controller will do, it will just turn on the heater and just keep it on 100% power until that temperature goes up. But what if your thermocouple just detaches from the board and flies off and you're not there to catch it? Right? What happens then is a fire hazard, because the heater will just continuously push energy until the temperature rises, and it will never rise because the thermocouple isn't there. For that reason, we have an additional safety feature over here, which is emergency shutdown. So if this is selected and the temperature falls behind by more than 25 degrees for too long, the device will terminate. So now my thermocouple has been detached, and you can see how the temperature dropped dramatically.
Process completed.
Alright, the device was shut down in the emergency mode. This is very important because this will happen to you eventually. Obviously the process takes maybe 5 minutes typically. Usually not more than that, usually actually closer to maybe 2-3 minutes. So probably this will not, you will most likely be there when it happens. But, you know, things happen, especially if you're alone in the shop and the customer comes in, you're in the middle of this. Technically, you can leave it be because it's automated, and once it reaches all the temperatures and goes through the cycle, it'll turn off and start cooling like it is right now. But if the thermocouple detaches, not only you're going to melt the socket if you're doing the socket resoldering, but you will also damage the board. And worst case scenario, you're going to burn down your shop. So probably the best advice is to always attend the machine when it's running. Don't leave it unattended. But we know what the reality is. Sometimes you have to, even if you're just going to the bathroom for a minute. That minute can cost you a board or a socket or both. So this is just a quick overview of the features we have in version 1.4. There's a few more features I didn't mention, but everything you need to get started is here in this video. Now the work on the software continues, and I'm still adding more features. As you can see, the whole advanced tab is still unpopulated. We have only one extra feature over here. There's plenty of more features coming. There's going to be a further analysis of the output power and the actual ratio of how much power do you have to put in to increase the temperature by certain amount, a certain number of degrees. That tells you the efficiency, how efficiently the heat from the heater transfers onto the board. That in turn can allow the software to detect when the thermocouple is not installed properly. One of the mistakes that I made when I started working with this device is I covered the thermocouple with Kapton tape. So it was touching the board and reading the temperature of the board, but it was not reading the temperature of the heater, which resulted in melting and damage to the board. So this will allow us to detect such a scenario and just calculate that there's too much power going into the board and not enough feedback from the thermocouple, and prevent you from damaging the boards, just like we prevented the damage over here by removing the thermocouple. There will be a product page on blackhorserepairs.com where you can download the software from, but at the moment we are pre-release. So if you would like to participate in beta testing, feel free to join my Discord and get the link from there to download it. At the moment I just host it on a Google Drive. The software is not signed, or at least not signed by the key that I bought. It is basically self-signed. That's why it says that it's unknown publisher. Your antivirus might have a problem with that. You might see the window that opens if you use AVG. It'll say that it's the suspicious software, and it'll open the software just to take the screenshot and monitor what it does, and then give you the confirmation that there's no threats detected in the software. It doesn't connect to the internet. It doesn't spy on you. It doesn't do anything like that, at least not the free version. There's always going to be a free version, but there will also be paid versions of the software, which basically, if you're a more serious shop, first of all, you can afford about $20-25 in a single payment, or $10 a month for the monthly license. You're gonna need those extra features. But for the typical small shop like mine, the free version is all you need. Alright, and with that, I thank you very much for your attention. If you want to support this software, just download it. It's absolutely free at the moment. If you want to participate in the software development, hit me up. We can collaborate. If you would like to request some features, definitely let me know. I would like to pack it with as many features as I can, and I want it to be as usable as possible. Now, at the moment, we only have a Windows version, but since it's written in .NET, there's going to be a Mac and Linux version as well. Thank you guys very much for watching. I do appreciate you, and I shall see you in the next one.